All right, so basically what I wanted to talk about was how on earth are we going to get all of this to compute? We have access to a laptop that will be able to process all of our data, but anyone that took ECE480 knows that whenever you loop over an image, it takes time to process that image. Our data set currently contains 1,200 XX, I don't know, couple images of just positive data. So we have 1,200 images of pedestrians. Then for our negative sample, for our zeros, not our ones, we have 12,500 some images of that. Now, after we have those images, we actually have to take them, flip them all over the place, and we end up generating 4 times that much data. So we have over 40,000 images that we're going to have to process and put into our classifier. To do this on the laptop might take, maybe a week or 2 weeks, I don't know. But so what we decided to do was we asked Dr. Punch for access to the High Performance Computing Center. We upstairs, I don't know if anyone knows this, but we have access to like 3,000 terabytes of data. Can you go to the next slide, please? Yep. So actually we have access to 6 different clusters of machines. Each one of these clusters has X number of nodes, but when you total all of this up, we have 3,584 cores of processing power, or 3,500 laptops available to us. Computing 80 to 8,200 terahertz, 107 gigabytes of scratch space, that's not total space, or 8,000 gigs of RAM. So it's a lot, we have access to a lot more power when we use one of these. So what we do is we actually ask the cluster for a small amount of this chunk of data so that we can have access to this and process. You go to the next slide, please. All right. So our development environment that we're working with is we just remote in. Just like anyone remotes into Black or the DEX server, or we just have remote access to MATLAB that runs on this development node. This development node, also known as AMD09, it's one node that has 32 cores and 256 gigabytes of RAM. So we develop everything here, but we end up submitting it to the cluster. Can you go to the next slide, please? Yep. All right, this is a big layout of what we're using. So what we do is we start out here, and we have access to the development environment, which is this node right here, which is actually part of this cluster. There's 4 big giant nodes in that one, and we really just use that most of the time. So what we do is we just have this big giant MATLAB script that will go through, process all of our images, and then go through and create a support vector machine with all of those images. In comparison for time, we're just running on maybe 20 minutes runs our entire generation time rather than a week. What's going on here is when you submit a job to the cluster, you're actually just asking it for X number of whatever you need here, and it gets processed. You really have no idea where you're running, so you have to have a good idea of how much space each one of these has. The great thing about it is each one has more space than any computer that you'll probably own in the next 5 years. So, does anyone have any questions? Yes?
So is all your time spent pre-processing that?
Not pre-processing. We spend half of our time pre-processing, so we have to create our support vector machine model. We do all of that pre-processing. And then on the board, we end up doing all the pipelining stuff in real time, or we're attempting real time. Our board's a little bit slower. It's about, 6, 7 years old? 5 years? It's a little, our board's a little bit old. I mean, it goes back a little ways. So we're trying for real time, but if we end up with, 1 frame every 3 seconds, that's what we're gonna have to deal with.
You talked about classifiers. Did you individually go and find all your classifiers for, say, cars, pedestrians, etc., and make your own database?
Well, what we're trying to do is that's something that we can do, but what we'd have to do is we would have to get a positive data set for cars, train the support vector machine with cars, and we have to get a positive data set for people, train it with people. Negative set of both sets and combine them together. So we're trying to get one set to work right now. Essentially what we could do is create a big giant one, but we don't have the hardware resources to do that.
In case it's unclear, when you're training a support vector machine, basically you take the image, and then in our case, because we have a histogramic gradient system, you take the histogramic gradients of the image, and then you tell the support vector machine generator whether this image contains what you want to find or whether it doesn't. And then from there, the generator takes all of these points and it computes it, or throws them into its model, and then it adjusts basically the hyperplane so that it's on the right side of the line.
So you guys are doing, you guys are representing vectors and then dividing by them after you normalize them on the board, is that true?
No, basically we're just adding up all the individual values in the vector.
Mm-hmm.
So it's,
Well, you have to normalize them, so you have some hardware division.
we have a hardware,
So
So-
dividing in hardware is hard.
yes.
Yeah.
How do you do it?
Xilinx has a
Well,
block specifically
okay.
designed for that.
Yeah, we didn't.
Okay, yeah, that's
yeah,
cool.
we're
No,
not
it's-
making the
yeah,
transistor
so,
divider, but
so then I guess the next thing is it floating point or is it just a numerical
It's fixed point.
approximation?
It's
Okay,
fixed,
so it's
yeah.
fixed point. Okay, that's cool.
Okay, good questions from the class, so I won't ask mine.
sure.
All right, thank you. For those of you who came in late,